Hi, I'm Seth Johnson with PowerSide. Today I'd like to introduce a new configuration to our PowerMVar series product line. Our PowerMVar series product is our medium voltage reactive power compensation and harmonic filtering product, which we use from 2.4 kV up to 35 kV class. What you see here is a 11 kV system that is built for a customer that needed to use our systems in a portable manner. And as you can tell here, this is a containerized solution. So this is just an average container that you can buy. And we have utilized it in a way to design a medium voltage filter. This filter is a 2-stage medium voltage detune filter, 5MVar at 11 kV. Fairly basic. The control, which we'll look at in a minute, is power factor control, and we have the ability to, of course, manually control it. You'll notice here we've got our reactors, which then feed our capacitors, and then in front of that, of course, are our vacuum switches. So again, a 2-stage configuration, not extremely complicated by any means. The way it's configured, of course, is our incoming section here. It's going to be an underground feed. So the client will come in here with their incoming medium voltage cable, terminate on the bus. So we've got all our 3 phases and of course the ground. And then from there, we're feeding each of the stage sections. Fuses, of course, to protect each phase and on each stage. And those go to these micro switches here, which detect if a blown fuse indicator has occurred, or a blown fuse situation has occurred, which then comes back, of course, to the control. We have lights inside here, which the client had requested, as well as anti-condensation heaters for the bank. And then as we move over on this side, we've got our ground switch here. So of course we use this to, before opening the doors and for the Kirk key interlock scheme, we'll close the ground switch, and then we can get into the bank and access or service any of the components needed. We've got a control power transformer up here, which is providing the 120 volts for the control power, which is also powering these lovely fans for ventilation. So, you may be wondering, okay, why do a containerized design? Well, there's many benefits. One of them is containers are readily available. They're used in many applications. A lot of folks are using them in battery energy storage applications, renewable projects as well. Obviously, there's plenty of room here as well. You can see the doors are open. We can service and build everything quite quickly and easily with this type of design. The other thing to keep in mind is that these are stackable. So we could get into a scenario where we're doing a multi-stage, multi-tune filter where we may have a container on top that has the reactors, and we've got capacitors on the bottom, or various other configurations. Those are all part of what we do here at PowerSide. So with that, let's go ahead and move over to the control. I'll close this door here, and you can see quite robust. Another real benefit here for this client in particular is that this is going on to it's not going to be on a concrete pad, but on a gravel foundation. And with how robust these containers are, there's very little distortion with the enclosure, so you don't ever have problems closing doors or anything like that. And again, if they move that, and when they decide to move it to another location, very little risk of damage to the enclosure, and it's also quite portable. So here we have our control enclosure, and this is built per the customer's requirements and specifications. Again, we're primarily using this in power factor control mode. The main function for this bank is to do power factor control, and we're trying to eliminate the risk of resonance by adding the detuning reactors in front of the capacitors. This was a requirement once we did a harmonic study and looked at the total of 5MVar that's required on the system. It needed to be a detuned system. So here we're using our power factor controller here. This will be set up with a current transformer that is sensing the load upstream, and then the controller will close the various stages as the load changes and as the load requires more VARs to maintain the target power factor, which is pre-programmed internally here at 98%. Now, on all of our medium voltage banks, we have the ability to run them in manual mode and automatic mode. And so we can simply flip the switch here. Everything's running through our power factor relay control. Or in manual mode, I can go here, I can select each individual stage, open and close the stages. And of course, these have timers that are built in back here. You can see the nice work the team does here when it comes to control panel wiring, something we certainly take a lot of pride in here. So, you know, this is somewhat of a new product for us, but we're seeing demand for it in the renewable energy space, renewable markets, as well as even in some commercial industrial applications. So please feel free to reach out to us at PowerSide, sales@powerside.com. Follow us on LinkedIn, and thanks for tuning in.